a short detailed review of web programming, or the story of the software web stack. So you got a website, you got a server. How do these things communicate? They communicate over a TCP connection using HTTP as their method of communication. So how do you communicate over a network? There are lots of ways, but there's one big popular way. It's called packet switch networks. If you want to learn about the other ones, you can. This is TCP. How do you guarantee reliability over an unreliable network? IP is unreliable. It does not guarantee that data has been sent. But TCP does guarantee reliability, and you communicate over sockets that have ports. And this is how it actually guarantees the reliability. First, you send SYN, and that says hello. And then the server sends an acknowledgement of your hello, so SYN acknowledge. And then you send an acknowledgement of that acknowledgement. Then you start sending your data, and then it sends an acknowledgement of your data. And then the server sends some data, but it didn't get there. So the server didn't hear the acknowledgement that I sent back because it didn't get the data, and it now sends another copy of that data, and I send that acknowledgement, and then it sends more data, and basically at the end you say I'm done, and then it says I acknowledge that you're done, and then the server says it's done, and then you acknowledge that it's done, and then the connection's over. This is a TCP packet. You have source destination sequence number so that when it comes back together, some might be a little bit late, you can put them all in the correct sequence, acknowledgement numbers, and then you have your data and all the other interesting stuff in here. This is how it's actually routed. It goes down from the application level to the host, to the internet, to the link, and then back up and over and up, and again, back up to your application. UDP is a little bit different. UDP is more about not guaranteed to get there, but it's guaranteed to send right now. And it's about speed. Games use UDP packets to communicate. And it doesn't really matter if they lose a couple or they come in different order. This is the important thing, is sending it. This is a UDP packet, much simpler. Just length of the data and then source destination and a checksum. And then all of that gets inserted into an IP packet. And this is how IP packets look. This is a TCP stream. You can send in and out of this stream. You can send hello. And how hello is actually sent is in binary. You can also send integers, other binary data in this stream. But you got to know what you're going to be sending. So you have to agree beforehand how you're going to be communicating. And HTTP generally communicates using text. And you can encode text in many different ways, binary encoding. The big popular ones are ASCII and update. Let's say 65 is going to be A. It's going to be capital A. And A is going to be 97. And this is how you send text. Hello world, this is hello world right here. All that is binary for hello world in ASCII. And then what you can do is you can actually encode binary into text and send it over your text-based communication with a TCP port. And that's usually called base 64 encoding. There's a bunch of other ones out there. HTTP functions as a request to response protocol in a client-server communication model. So there must always be a request, and then you always get a response. So websites create these requests, Firefox, Chrome, IE, and then it sends it to the server, and then the server responds either using PHP, ASP, or JSP. And there's one exemption. It's called a postback, and it's usually used in e-commerce solutions. So you have your store website, and it has the credit card information, and you're going to send that credit card information to a payment processor. By the time the request is over, it hasn't processed the payment yet. And so what it's going to do is it's going to know that you're this site, and it's going to come back and send a request to your server saying, hey, I finished this. That's how payment processing generally works with a postback. HTTP can both send files, binary files, and text-based files. And it can send in different encoding schemes, and you basically can also use base 64 encoding to send bitmaps back. You can also use it to store emails with built-in images using MIME encoding. HTTP also requires a lot of dependent technology, URLs, DNS, and the rest of the Internet Protocol suite. There's a lot of technology on top of HTTP. But HTTP is actually really easy to understand. It's human readable. There's very simple methods that are used, get, post, and head. There's HTTP 1 versus 1.1, and then there's some status codes, which we'll talk about. There is also the typical communication port, which is port 80. So this is a request. It says get, that's the method, and then what you want to get, which is /index.html, and then the protocol that you want to use, and then your host that you're actually asking for. Because what happens is, think of it like a telnet server. You can actually connect to HTTP servers and use it like a telnet server. And you're asking for a specific host. So you could have multiple web servers running, and you're looking for a very specific host. This is sort of how they determine that. This is the response that you get. You get an OK200 OK response with a header, and then the HTML basically saying hello world. The methods that you can use, 1.1 you get head, get, and post. Head just gets the header, get sends the data in the URL, and then post sends the data in the body of the request. There's also some more put, delete, trace, option, connect, and patch, but I'm not going to talk about those. Head just gets the header. This is what a head request looks like. A get request, you can just get any old request, and get will work. It will send back this request. But say you want to encode some data into this. So now you say get index.html question mark name, and then the name of the person, and then and the age, and then equals 23. And then you ended it with HTTP1, and then your example. There are some limitations as far as how long these URLs can be. That's why they also created post. Post allows that same encoding of data, but not in the index.html question mark. It actually shoves it at the end of the request. And this is how you actually upload files. This is how you make information more private without people can examine the URLs pretty easily, but they'd have to look at their packets a little bit differently. And then you have a content length of 24. That's because it's 24 characters long. This is for passwords. This is for private information. And then you can also send files this way too. You'd base 64 then. You send it as text. HTTP is an inherently stateless protocol. So it doesn't know what you did yesterday. It knows what you're doing now, and won't know what you're doing in the future, because it doesn't hold state as far as a shopping cart. So think of a shopping cart. You add something to your cart. The next page you reload it, and your shopping cart's empty. You need a cookie to store this stuff. So what happens is you make a request. It sends the response back, and it says, hey, sent these values as cookies for you. The browser is going to store this and then send any cookies with the next website request to know, hey, this is me, and these are my cookies. HTTP 1 versus 1.1. The only real difference is the additional methods, and then HTTP 1 allows multiple items or multiple resources to be sent under one connection. Instead of sending 5 connections for 5 different resources, 1 connection with 5 resources. These are HTTP status codes. These are the popular ones. 200 is okay. 301 and 302 are redirections, so it's permanently redirected or temporarily redirected. You have 404, which is not found, forbidden, unauthorized, bad request, and that's basically HTTP and TCP. Now let's talk about what your browsers bring on top of that. So your browser first opens the connection, and your server listens for that connection, and your browser then sends the request, and the server parses that request, pulls out the parameters in get and the post, and then passes them to produce the actual HTML either dynamically or statically, and then it sends back the request, it sends back the response, and that response then pulls out the HTML, converts the HTML into your document object model, stores all your cookies, renders your document object model, and then runs any JavaScript. So this is a very simple HTTP server. You have the head, the HTTP header that we're going to use. We have the actual text, and then basically server socket welcome is the actual socket. That's what we're going to be opening, and then we're going to print ready to screen, and then it's going to listen. We're going to then pause at this line because now it's waiting for a connection thing, and then basically you have to use your web browser, and then it starts running the next protocol. So it's going to process the web request. We also have to set up the streams that we're going to use. We need the input stream, which is in from client, and then we also have to set up the out stream or the output stream, and that's out to client using the connection socket.get output stream. Here's the actual server right here. It's actually really quite simple. We're going to process the request from client, read line. Now this is the problem with this program right here. It only reads the first line of any request. This is actually where the HTTP server actually comes into existence. Split the request to just get the get out with the spacebar. We're going to check to see if it says get. If it says get, we're going to then check to see if it says /. If it says /, which is the thing that it's actually requesting, we're going to send this response, the HTTP header plus HTML. And then we can also check to say if it says index.html, and we can actually send out a static file from that. We attach the header, we read the file, and we send it out. Then we can also do some JavaScript processing, and then what happens is we take that response, we send it, write it back to the client, we print the response in the console, and we close the socket connection. This is a static website. We're requesting /, and there are some routing rules as far as what does / really mean. Does it mean default? Or does it mean index? And then those are your server rules that will just basically say, hey, go to this file. So we're listening, we're getting a get / HTTP / 1.1. And then we say, we're checking if it's a get. Yep, it's a get. Is it /? Yep, it's a /. Then we basically put the header and HTML together and send the response. And that's how we get this website displayed. But say we want to dynamic websites. Now, we're going to be testing the same get, and this is the request over here. It says get / index.jsp name, that's a parameter, that's a key value pair, so it's going to be name and then the actual value, which is going to be Bob. So you can have a bunch of these with the little and sign, and then more and more and more, up to a limit of, the server limit that accepts the URL. And then what it's going to do, it's going to process this. So this is first checking to see if there's anything that says JSP in it. So index of basically checks for whether it says JSP. I didn't really want to write that index.jsp and then parse all that stuff. But if it finds JSP, it's going to run this JSP program. And it's going to pass this whole parameter value, the whole thing, / index.jsp name equals Bob. It's going to pass this into this. And then I'm just going to say anything after the equals is what I actually want to display. There's more there's more programming that will take care of this issue of passing just the key value pairs that you want to do. But I didn't want to do that. So you have your string, you have your HTML, you're now going to say hello bold Bob and then return that. And that's how dynamic JSP sort of works. You want to learn about CSS and HTML. This is actually a pretty interesting topic that I don't have time to go over. You want to learn about JavaScript. This is a very important topic. You also want to learn about MVC, the Model View Controller. You really don't get this until you start building websites with the Model View Controller, and then you sort of understand it. So now we're on to databases. Databases are an important part of websites because you got to get the data from somewhere. You have to open up the connection. You have to execute your SQL. Sometimes you're going to get nothing back from an SQL statement. Sometimes you're going to get something back, just a single object. Or sometimes you're going to get a list of tables and a list of objects. So you have to now parse that table into the objects or the list of objects, and that takes special code. And what you can do is basically, what you really want to do is just manipulate plain old C objects or plain old Java objects to make it simpler as far as the database goes. And then you just return those things to the database and saying you're updating these things. ORM tools, these are very easy to use. Entity framework, I like that. Hibernate's pretty good too. You want to once you did this the first time, you probably don't ever want to go back to writing raw SQL and parsing these objects yourself. Entity framework takes care of all of this stuff. Typically, you start with one database and then you go into partitioning and sharding, and then as far as the database goes, in there it's actually pretty hard to scale up a database. Scaling up and scaling out. Scaling up usually means that you get a better computer, and the reason why you scale up is because you have licensing cost issues with the number of computers that you can have in your server pool. Scaling out, usually you're using open source software, and that means you can just buy more computers. Facebook uses scale out. Stack Overflow uses scale up because they're a Microsoft shop. Things that you want to learn more about, you want to learn about Angular, you want to learn about jQuery, you want to learn about Node.js, and then Fiddler. Now you understand how to program websites.